Hello, I'm Jill Morris, and today we will be talking about the best practices to combat the invasive species buckthorn from Midwestern forests. This information was taken from the paper Effect of Method and Time of Management on European Buckthorn Growth and Development by Jennifer Bissaqua, Martha Nadakunda, and Roger Becker. This article was published in the Journal of Scientific Agriculture with an impact factor of 2. Buckthorn is an invasive plant in eastern and midwestern forests in the United States. It was first planted as an ornamental because it tolerates many different types of soils. People like buckthorn in gardens because it has an attractive dark green foliage that stay on the stem late into fall. It's easy to grow and it makes many dark blue berries that attract birds. It can live in full sun or tolerate full shade. It negatively affects native forests by reducing understory germination and growth. Buckthorn forms a large crown, shading plants underneath it, and because it can tolerate many different sun levels, it outcompetes native plants. It also grows more quickly than native plants and can host major agricultural pests, such as the fungus that causes oat crown rust disease and the soybean aphid. Much of Minnesota farmland is grown as crops, so a plant that can overwinter a pest, such as the soybean aphid, is not something we want around. Previous studies have shown that buckthorn resprouts from the stem if it's been cut and non lethally treated with an herbicide. These resprouts actually form an even larger buckthorn plant than the original. This study wanted to determine the effectiveness of different control methods during the different seasons of the year. It also wanted to know how the control methods affected resprouting and reseeding of buckthorn and other native species after treatment. This is important because in order to restore the native forests, the best management plan would incorporate the regrowth and regeneration of native species. Their hypothesis stated that using more than one treatment measure would provide more effective control than using just one measure alone, and also that the use of burning would increase seedling emergence of both buckthorn and other native species. This table summarizes the average across all the different control methods, which I will describe on the next slide, but it compares them to the time of year the control methods were administered. Because buckthorn can resprout from the crown after getting cut, we measure if buckthorn is controlled by how many resprouts occur the following year after cutting. As you can see by the red arrows, fall and winter management had the most successful rates of buckthorn control because their resprouts per crown are the lowest, with fall being slightly better than winter. When we look at the slide after the one we are currently on, it will show the types of treatments used. So I wanted to take a moment to describe what the types of control methods were during this study. All methods including cutting the buckthorn plant itself, which is represented by the letter C. The S represents stump treatment, which means that after the buckthorn was cut, an herbicide was applied to the stump. Basically, the herbicide is brushed onto the remaining stump so that it covers the entire surface area. The herbicide used in this study was called tricloperamine, which is sold under the commercial name of Garland 3A. It is a popular herbicide with landowners here in Minnesota, and the general public can buy it over the counter. The last control method was burning, where the entire experimental plot went under a controlled burn. In this study, there were 5 different treatments. The first was a cut, a stump treatment, and a burn all together. The second was just a cut and burn together. The third, a cut and stump treatment together. Fourth, just a cut. And fifth, no treatment. This table shows both buckthorn resprouts and also the regrowth of buckthorn and other native species in the test area after the different treatments during the spring season. Starting with buckthorn resprouts, you can see with the red arrows that the control methods that included the stump treatment of herbicide had no resprouts on average. You will also notice that the cut and burn treatment and the no treatment provided similar results as seen with the blue arrows. And with the green arrow, you will notice that cutting only produced significantly more resprouts per crown than any other treatment method, including no treatment at all. You will also notice that the control methods that included burning resulted in really high density levels of both buckthorn seedlings and native plants in the area. All other treatments showed similar amounts of buckthorn seedling density and density of other seedlings, including the no treatment option. On this last table, we focus on only two different treatments, the cut only and the cut and stump treatment with herbicide, compared to the time of year that the treatment was done. You will notice that when the cut only was done in the spring and summer, the resprouts per crown were relatively high. However, when done during the fall and winter, the resprouts were zero, as shown by the red arrows. When looking at the cut and stump treatment with herbicide, the resprouts per crown were zero across the board. The data shows that the best control methods for buckthorn is a combination of cutting and applying an herbicide. The combination of these two treatments left buckthorn with zero resprouts. However, buckthorn also had zero resprouts when cutting during the fall and winter seasons. Burning after cutting, no matter what other control methods were combined with it, results in more seedlings of native species. This is mostly because burning rids the ground of excess organic matter, which allows plants more access to sunlight and an unhindered pathway from the ground. However, burning also produced many more buckthorn seedlings as well, and because they outcompete the native species while growing, this could prove problematic. While having more native species seedlings can help with restoration of forests, the amount of buckthorn seedlings would need more control measures to happen in future years in order to make sure the buckthorn doesn't dominate the landscape again. Current measures for buckthorn control include using large mowers that cut brush on large scales during summer months. This study could help update those procedures to change to different seasons, because cutting alone in the spring and summer seasons actually increase the amount of buckthorn. Previous studies have shown that cutting alone resulted in vigorous resprouting, but the data from this study suggests that if cutting alone happens during the fall or winter season, it can be effective at controlling buckthorn, which would alleviate the use of excess herbicide applications. So, if we could get those big brush cutters to cut during the fall season before snow falls, we might have better success. This study also suggests that more data should be collected, specifically focusing on the plant age and size. Although plant age and size were not included in this study, the scientists did make several notes that they noticed trends with the size of buckthorn versus the control method. Perhaps if we can catch buckthorn before it gets too old or too large, we could find easier, less expensive, and safer ways to restore our native forests.